going to do that, but I'm leaving it here as an idea for you to do that. Now anyway, let's go now to the next video and actually start to implement the login functionality. Let's now finally implement the login feature of our application. And this is going to be a lot of work, so let's get started right away. And to start, let's take a look at our demo application. So in this case here, in the beginning, we cannot see anything. So there's no logged in user. And then we can input a username. And so this is the kind of username that we computed before. Remember? And then the PIN. And if that is correct, so if the PIN corresponding to this account is correct, then we get logged in. And that's going to happen whether we click on this button here or hit the enter key. And so then all of this appears. So all the values here are calculated. And yeah, so that's the main thing that we need to do in this lecture. And then of course, if someone else logs in, then their values are going to be displayed. And so let's take a look at the HTML here of this form. So indeed, here we have a form element, and this form has a button. And so it's onto this login button that we will attach the add event listener method. Then, as for the inputs, the username is going to come from this one with this class, login user -- input, and the PIN is going to come from this one. And as always, I already have all of this here selected. So this is the button here. And then we have input login username and input login PIN. Okay, so let's now create these event handlers. So event handlers right here. So button login, add event listener for the click, and then as always, our callback function. And here, let's just log to the console login. Okay. And now, did you see what happened here? Take a close look down here what happens as we click. So for a flash there, you saw the login and then the page reloaded, right? And that's because this is the button in a form element. And so in HTML, the default behavior when we click the submit button is for the page to reload. So we need to stop that from happening. And for that, we need to actually give this function here the event parameter. And let's just call it event. And you already know how this callback function gets access to this event object, remember? And so on that event, we can call a method called prevent default, like this. And so as the name says, this will then prevent this form from submitting. So prevent form from submitting. So let's do that again. And now we fixed that problem and we can see login. Okay. Now another thing that's great about forms is that whenever we have one of these fields here inputted, and when we then hit enter like this, then that will actually automatically trigger a click event on this button. Okay. So once again, hitting enter in this field or in this field is exactly the same as the user clicking right here. So both of these things will trigger a click event. So you see, as I hit enter, we get more and more click events. So that's why we get then login logged to the console. But now let's do the actual work. So to log the user actually in, we need to find the account from the accounts array with the username that the user inputted. And so that's where our find method comes into play again. So we can do accounts.find. And then this is actually the same that we did in the last video. So account.owner should be the same as, so 3 equals actually. And so remember, we have this value at input login username. Okay, so that is this element here. And then from there, we need to take the value property. Remember that? So we did this here, I think in the guess my number game, where we also read the value out of an input field. And so here, this is the same. And so now let's actually save this into a variable. Now this variable needs to be defined outside of this function. Okay, and that's because we will need this information about the current account also later in other functions. So it's a good thing to have this big important information outside of this function so that we can then remember it for other actions in our application. For example, when we transfer money here, then we need to know from which account that money should actually go. And so for that, we need the current account. So current account, and here we just define it, and that's why we need a let. And so then here we assign it this value. So current account. Okay, so let's check that. So JS, and we get undefined. So there was some problem here. And the problem is, as I see right away, is that we are looking for the owner, but we need to look for the username. So the owner is the whole name, but the username property is these properties that we created earlier. So here in this function, remember? So we need to compare this value here that the user inputs, of course, to that username. So try that again. And now here we get the object which has exactly this username. All right. And so it is here my object, basically. All right. So we got the user that is trying to log in. And now all we need to do in order to actually log the user in is to check if the PIN is correct. So PIN here is like a password, but something that we usually use like in an ATM. And so I decided to just go with that here, because I think this also looks a little bit like an ATM machine here. So let's then do that test. So if current account dot PIN is equal to input login PIN. Okay, so that's the variable that holds the selection of selecting this element. And then again, we need to take the value. And finally, we also need to convert this to a number, because as I mentioned earlier, this value will always be a string. All right. And so here, before we do anything, let's just log in again here to the console. Okay. So JS, and we got logged in. But if we only input JS, then we simply get the object itself, but without being logged in because the PIN is correct. And now let's try just some other user to see what happens here. And we get an error. So that error is cannot read property PIN of undefined. And so the reason for this is that this object here is now undefined, right? Because no account could be found for this username. And so the find method, so this one here, will return undefined if no element matches this condition. So that's something that we haven't seen before, and so that's why I'm showing this to you. But anyway, how should we solve this? Well, the first thing that might come into mind is to simply check if the current account exists, like this. Okay, so this would fix the problem, but we can do better because we already learned about something called optional chaining. Remember? So we can do this, and then this PIN property will only be read in case that the current account here actually exists. Remember that? And so this is a lot easier and a lot more elegant. So let's try that. And so now nothing happened. So no error. All we get here is the undefined because yeah, this account does not exist. But that's, of course, not a problem. Okay, but now in case that the account does exist and that the PIN is correct, what should we do? Well, let's take a look at our flowchart here. So this is the part we already checked. So if we have the correct credentials, right? And so if yes, then we should display the UI and the welcome message. So let's write that here in our script. Put that here. And so I like to kind of plan out what I'm doing here using comments. So display UI and a welcome message. Next up, we should display and calculate the balance. Then the same with the summary and the same with the movements. Okay, this part here we are leaving for the next section about the timer. Okay, so display balance, summary, and movements. So display movements, display balance, display summary. And let's start with the message here. So that is this element here. So let me inspect that. So it's this paragraph here called welcome. And so as always, I already have that selected. So it's a label, so probably it's called label welcome. Label, indeed, here it is, label welcome dot text content, as always. And then here we are going to write welcome back and then the first name of the person. Welcome back. And then the owner of the current account. So that's current account dot owner and then only the first word. So how do we do that? Well, we use our good friend split. And we split it with the space. So as I said, we use this one all the time. And then from the resulting array, we simply take the first element like this. Okay, so this displays the message. And now about displaying the UI, remember how in the beginning we set the opacity here from 0, basically back to 100, which is the default. So usually the opacity here is at 0. And so now when we log the user in, we actually set this opacity here to 100. So as we save this now, it will all disappear. And so now what we will do is the container app, I think. Yes. So container app is the element that we selected previously, which has this app class. Okay. So this element, we will manipulate the style and in particular the opacity style. Now remember how I said in another project that it's also good to use classes for this. Okay. But in this case, it's really just one style. So it's not a big work to just do it like this. So let's test this one out for now. So JS and my pin. And indeed, we get our message here. And also we get everything here now back to visible. And Jessica Davis now, which has pin 2222. And so now we also get Jessica. Now, as you see, these balances and these movements here, they're all still hard-coded from what we had back here. So here we called calc display summary and also the balance and the movements. But now we want to do that not here, but actually inside of the login function. So let's remove all of this. Again, because we do not want to call these functions right in the beginning when our script is loaded. We only want to calculate and display the balance and the movements and the summary as soon as we actually get the data that we want to display. Right? That makes sense. So let's remove all of that and actually do it here. So display movements, and then it is the current account dot movements, right? And that's because this method here, or actually this function here, it expects a movement argument. And as we hover this function name, VS Code is so smart that it actually shows it to us here. And so from there, we can immediately see what we need to pass into the function. So that's really handy. Then the same with the balance. So display, or calc display balance actually. And so once again, let's just hover this here to make sure what we need. And it is the movements. So that data is stored in the current account dot movements. And finally, also the summary. So calc display summary. And once again, we will need the movements. So that data is in current account dot movements. All right. Now we will have to come back to this function here by the end of this lecture. But for now, let's leave it like this. And let's log in again, first with Jonas. And so this is the data that we are already used to seeing, this balance value and this movements here, because we have always been printing these values here using that account. But now, as we log in as Jessica Davis, you will see that these values here will all change accordingly. So let's see. And yes. So that's great. Now we are getting all of these values, so this data here dynamically really from the account object itself. So we have all her movements, we calculated all of these statistics or summaries, and of course also the balance is now really about this account itself. And we have more. Let's try Stephen here. So Stephen Thomas Williams with pin 3333. And this kind of messed up our UI here because of this calculation. So Stephen only has a balance of 10 euros. And now finally we can try Sarah Smith. And so once again, we see all her different movements here. And yeah, this is great. So this now really works depending on the user's data. So let's go back here. So what I want to do next is to, as we log in, also get rid of this data here. Okay, so basically emptying these two fields. And also as we log in like this, I didn't want this field here to lose its focus. So let's do that before this. So clear the input fields. And so we already know that the fields are input login username, which we want to set to the empty string, and then also input login pin. And we can do it like this. Login pin, also set it to equal, because the assignment operator works from right to left. So it will start here assigning equal to this field here. And then this here will become the empty string. And so then empty string will also be assigned to this one. We are just missing the dot value here. Otherwise, we would set the entire element to the empty string. All right. So JS 1111. Okay. And now this happens, what I mentioned before, is that this field here still has this focus. So we can see the cursor there blinking. And so that's a bit ugly. And so on that field, so input login pin, we can use this blur function or method. So just call blur. And so that will make it so that this field loses its focus. So you see, now it looks great. And now just to finish, we also need to come back to this function here, just as I mentioned earlier. So calc display summary, and let's go there. So this one here. And as you see, we calculated the interest using this 1.2 rate, right? So right now, for all of the accounts, the interest rate is now calculated using this 1.2 interest rate. However, as we take a look at the accounts, each of them actually has a different interest rate. So this one has 1.2, but this one has 1.5. And this one has less, so it gets a less interest. And so now, of course, we also want to dynamically use this interest rate depending on the current user. Right? That makes sense. And so we have to modify this function here a little bit. And so in order to get access to that data, so to that interest rate, we now need more than just the movements. Instead of the movements, we want now the entire account, because then we can take the movements from the account and also the interest rate. All right? So again, we will now change this function and pass in the entire account and not just the movements array. And so then from there, we will be able to take the movements that we need to calculate these three statistics here, and then also the interest rate that we have here. So account, let's just call it, or let's just call ACC one more time. So here now we need to take the movements from that account, the same here and here. All right. And now here, instead of this 1.2 fixed rate, we take ACC dot the interest rate that's in there. All right. So let's just see if everything still works. And let's see it with Steven. So that was STW and 3333. And you see that now our UI is no longer messed up. But of course we forgot to call this function here correctly. That's probably why we got this error. Yeah, right. So down here we are still calling this function only with the movements array. So we need to instead pass in the entire account, because as you see, now we do need the account here. So try that again. TW. And so now we get the correct interest. And maybe you remember that before it was different. It was this crazy long number with a lot of zeros, which messed up our user interface here. So this means that it is now being calculated differently for each of the user according to their own specific interest rate. Great. And with this, we implemented all of the tasks that we had in our flowchart for this functionality. And in practice, what this means is that for the first time, we made all of this data that we see here in our application dynamic. So depending on which user is actually logging in. So let's see that change again. Let's try a wrong pin here. And so now nothing happens. And of course, we could now hide the user interface and display an error message, but I want to keep it simple here. So this is just a simple learning application, so we don't need to mess with all of that. What matters is only the correct version for now. And so with the correct pin, now as you saw, the data changed here back to this Jonas account. Awesome, that's great. So that's really great progress. Congratulations for making it this far in this section. I know there's a lot to learn and a lot to take in, but I hope that this lecture too was clear to you how everything worked here. And just to recap, clearly the most important part here is the usage of this find method here and knowing that this is the correct method for the job. So maybe analyze this line here a little bit and then see exactly what happens here. Also this nice usage of the optional chaining. And then we are ready to implement our next feature, which is going to be transferring money from one of our users to another. In this video, we're going to implement our next feature, which is to transfer money from one user to another. And this is how transfers work. So here we input the username of the user to which we want to transfer, and then here the amount. Okay, and so now we need to attach an event handler to this button here. And then we're going to take a look at our flowchart to see what we have to do. Okay, but let's start to take a look here at this element. So it is the button form, and then we will take our values from form input amount and form input to. So that's input transfer to and input transfer amount. And the button is button transfer. So as always, I already selected them here beforehand. So let's use button transfer dot add event listener click and then our function, and we will actually need our event here again, because just like before, we need to do event.prevent default, because this one is also a form. And so without this, if we clicked here, then that would reload the page. So this here is pretty common to do when we're working with forms. So preventing the default behavior. Okay. All right. So let's create some data here based on the input data, and starting with the amount. So the amount to transfer is input transfer amount dot value, and then we need to convert it once again to a value, or to a number actually. Okay. Oh, and now as I reload here, of course we lose all this data, so this current data that we need. So now we will have to start to log in always here. And we could find a way around this, but yeah, let's just keep logging in whenever we have to check our code. So anyway, we have the amount, and then we also want to figure out the account to which we want to transfer. So const receiver account, and now the value is of course in input transfer to dot value. So that is the string that's going to be right here. So for example, if we want to transfer to Jessica Davis, that's going to be JD, right? However, that value alone, so that username alone, is not that helpful. It is only helpful when we use it to then actually find the account object to which we want to transfer. All right. And so for that, we once again use the find method. So that's accounts. So that's the array holding all the accounts. And then we have the current account, and we want to find account where the username is equal to this value that we put in here. All right. So to recap here, we are now looking for the account which has this value here. So that's going to be the username value that we input into that form, so to which we want to transfer. And so here we are looking for the account with the username which is equal to that inputted username. And then we select that from the account once more using the find method here. Okay, so we have this data. Let's just check if it is correct here by logging it all to the console. So also the receiver account. So this should be a comma. So I'm logging in as JS with this pin. And now let's say I transfer to Jessica Davis. That's JD, 100 euros. And now in the console, we indeed get 100 and the account with the username that I just inputted there. Great. So let's see what we have to do now. So what we will do is to add a negative movement to the current user and add a positive movement to the recipient. And that makes sense, right? So if I transfer 100 to someone, I should lose that 100 and the other person should receive that 100. Otherwise, we would just be creating new money, right? So we do that, and then we update the UI again. So we show again the movements, summary, and balance, because all of that will be affected by this transfer. Now, what's kind of missing here in this flowchart is that we also actually first need to check some stuff. So we need to check if the amount here is actually a positive number, and we also need to check if the current user, so Jonas right now, actually has enough money. So I should not be able to transfer 5,000 if I only have like 3,000 and something. Okay, so let's implement that check first. So as I just said, the amount needs to be greater than 0. Otherwise, we could do a negative transfer and basically transfer money to ourselves. So this needs to happen. And also, the balance of the current account needs to be greater or equal the amount that we're trying to transfer. Now, this balance value is actually not stored anywhere, right? So in the place where we calculate this balance, so that's right here, so calc display balance, all we do is to calculate it and then display it immediately on the user interface. But we do not save it anywhere. So let's actually change that. So besides only displaying it on the user interface, we also want to save it in the account. Now, how do we get access to that account? Well, we will do the same as we did previously with this function here, where now instead of the movements, we pass in the entire account. And so then we will be able to read the movements here from that account. And also we will be able to then create a new property on that account with the balance. Okay, so I hope that makes sense. So we are changing it from movements, and so now we will be calling it with an entire account object. So here we need to do account.movements, and before we move on any further, let's call this correctly. So calc display balance should now only be called with the entire account object and not only with the movements array. Okay, so here it is. So now we take the movements from the account object and then we can add that. So we can say account.balance equals balance. And in fact, we can make this even better. We can store this value here immediately in account.balance. So let's do that. Account.balance here. And then we get that property here from account.balance as well. Great. And remember why all of this works. And we have some error here, but that doesn't matter. It's something unrelated. Now, anyway, let's remember why all of this works. So why we can set this property here on this account object that we receive, and it will then set that right here on these objects that we have here. Well, and the reason is that, once again, all of these different references do actually point to the exact same objects in the memory heap. Okay, so when we access this account1 object here, so down here in the login function, so right here, where we create this current account variable, this is of course not really a copy of the object itself. So just as we learned before, this is simply another variable which points to the same, so to the original object in the memory heap. Okay, so this current account object again is exactly one of these objects that we have right here. So one of the objects of the account array, right? They are the exact same object, they simply have different name. Here it is called account1, but then down here it might be called the current account. Okay, and then we use that current account to pass it into this calc display balance function. And so then inside of that function, it will have even another name. So here it will be called ACC, but it's still the same object. Okay, it's still pointing to the same place in the heap. so in the memory. All right, and therefore setting the balance property here on ACC is exactly the same as setting it up there where we first defined the objects. Okay, and I will show you that in practice in a second. But now let's go here. And so this is where this error comes from, because we don't have any code block, and also because there is no second operand here. So anyway, let's go back to this condition here. So we already defined that the transfer can only happen if the amount is greater than 0. And now the second part is that the current user needs to have enough money to do this transfer. And so that means current account dot balance, which is the property that we just defined. All right. So we calculated the balance, and that needs to be at least equal to the amount that we're trying to transfer. Okay. Also, we should not be able to transfer money to our own account. So let's add that condition as well. So what we're trying to say is that the receiver account dot username must be equal from the current account dot username. All right. And here we have one equal too much. All right. And actually, we should also check if this receiver account actually exists. So if it doesn't exist, of course, it makes no sense to transfer money there. So we could add that here, like simply testing this. But instead, since we're already trying to read a property from that object here, we can use, once again, optional chaining, like this. And so then, if this object here doesn't exist, then immediately this here will become undefined, and the whole AND operation will fail. And so in this case, we don't need that. Let me just comment it out. And so now this should work. And so let's just log something to the console. So transfer valid. And now I will check all of these conditions here. So let's log in. And now I want to transfer again to Jessica Davis, and I will try to transfer 0. So we get 0, but we do not get transfer valid. So that means we didn't enter this if block here. Now let's try to transfer more than I have. And so this is also not valid. But now 500. And so all of these should now be true. So you see transfer valid. If I try something else, then again, nothing should happen. Oh, and actually it does happen. So indeed, the receiver account is undefined. And so this here will now be undefined. Oh, but I see what's happening. Because all that we are asking here is for this here to be different than the current account dot username. And so JS is of course different than undefined, and therefore this here is still true. And so in fact, we need to do this as well. So let's try this again. And so you see, of course, bugs like this can happen all the time. And so we find them, we fix them, and we move on. And of course, now we test with some wrong username there, and now nothing happens. Okay, so now the transfer is not valid. Now I'm also trying to transfer to myself, and so this is also not valid. But finally, to Jessica David, it will be valid. Okay, and so now here we can finally do what we intended to do all along. So these steps that we have here. So let's do that. So the current account dot movements. So we will add one new movement. And so we're pushing here the amount, but negative. So the negative amount. And now on the receiver account, we will add a positive movement. Okay, and that's actually already it. That's the most important part of doing the transfer. So doing the transfer. And then we also want to update the user interface. So we could now copy this code here and paste it there as well, but that's not a good practice, as you already know. And so I will now refactor this code here all into one function. So let me grab this here, and this function will be called update UI, and it will also receive, of course, the current account. So let me write now the function here, update UI equals function, and I'm going to leave it empty for now. And so indeed here I need the current account now. Okay, so otherwise I could not call these three functions then using the account. But here I can call them whatever I want again. So let me just call them account. All right. So we refactored that functionality into its own function. And so now we can call this function anywhere that we want in our code, and it will then always perform these three tasks. Okay. So here I already called it update UI. Let me just write it here also as a comment. And now all I have to do is to paste it here as well. Great. So that should be working already. So let's transfer to Jessica Davis 500. And so now I should see one negative movement here. And this should also decrease by 500. And indeed, it did. So let's check now here the accounts variable, just to see if we actually get the balance. So indeed, we now have the balance property here. We also have the movements, and of course, it's going to contain the minus 500, right? So that's the money that we just transferred away to Jessica Davis. And indeed, it should also already be in Jessica Davis. So her latest movement is now indeed 500. So let's check it out also in the user interface. Now, before doing that, the final thing that we're going to do is to clean these input fields. But now, just to make sure, let's log in as Jessica Davis, and then we should get plus 500 here as the latest deposit. All right. Now, as I was saying, we need to clean out these inputs now. And that we will do no matter if the transfer was successful or not. So we can do that outside of this if statement. So just down here. Or actually, we can do it right here. Let's get rid of this console.log. And then input transfer amount equal, or actually dot value equal input transfer to equal the empty string. And with this, we should be finished. Let's try it one more time. This time, Jessica Davis will transfer something. And so we lost here the latest transfer, of course, because the page was reloaded. And this data, of course, then gets lost. So when our page loads, the information about the accounts, so the account data, will always be exactly what we have here in our code. Okay, so that's the reason why that data, that 500 transfer, is no longer here. But that doesn't matter. So let's transfer to Stephen Williams here, 1000. And we get an error here, assignment to constant variable HTML button. So at line 167, and oh, one more time, I forgot the value here. That's a very stupid mistake, right? Let's try that again. Stephen Thomas Williams, I believe. And now it worked. So all of our statistics here were updated. And indeed, now this field, or both of the fields are empty. And now as we go to this account, oh, apparently it does not exist. Yeah, it is Stephen Thomas Williams. Yeah, so now we get this 1,000 deposit here that we just did previously. All right, awesome. So our application is coming more and more to life here. Welcome back. It's great to still have you here in this project. And now that we have a good grip on the find method, let me introduce you to a close cousin of the find method, which is the findIndex method. And the findIndex method works almost the same way as find. But as the name says, findIndex returns the index of the found element and not the element itself. So let's see a great use case for findIndex in our application here, which is the close account feature that we have here. And in our application here, closing an account means to basically just delete that account object from the accounts array. So from this one here. Okay. So for example, if Sarah decides to close her account, then this account 4 will simply be deleted, and that's it. Now, to delete an element from an array, we use the splice method, remember? But for the splice method, we need the index at which we want to delete. And where could that index come from? And you guessed it, from the findIndex method. So let's first select this button here and attach an event handler to it. And so that's the button close here. So let's come down here to our event handlers. Now we have multiple. And button close dot add event listener, click. And then as always, our function in which we need the event object so that we can call prevent default. All right, let's just test if this connection works here. Let's log in. And now as we click this here, we get delete. So that's great. And now let's take a look at our flowchart here. And so, yeah, the first thing that we need to do is to check if the credentials are correct. So basically, if the username that is inputted here is equal to the current user and the same for the PIN. So that doesn't sound too hard, does it? So actually, let me leave that for you as a challenge. So just write this condition here to, again, check if both the user is correct and the PIN. All right, I hope you did that. So let's first take a look at the element names that we have up here. And so that's input close username and input close PIN. So I hope you figured these names out here too. And so let's now say input close username dot value needs to be exactly the same as the username in the current account. So current account dot username. So this needs to be true, and the same thing for the PIN. So that's input close PIN dot value, and once again convert it to a real number. And this one also needs to be equal to the current account dot PIN. And now let's actually do the deletion itself here. So, as I already said, we are going to use the splice method to delete the current account. So let me actually start by writing that part. So we will take our accounts array and splice it at a certain index, which is the index that we're going to calculate in a second, and we will remove exactly one element. All right, and then the splice method actually mutates the underlying array itself, and so there's no need to save the result of this anywhere. All right, and so now let's actually calculate that index at which we want to delete. So we take the accounts, and now instead of find, we use findindex. And once again, this one takes a callback function, which is very similar to all the other callback functions we have been using. So it's going to loop over the array essentially, and in each iteration we get access to the current account, and then we want to find the one where the account has the username equal to the current account dot username. All right, and so let's then take a look at that index. And for now, let's actually take out this part. Okay. And we will then come back and maybe explain this a little bit better. So as I click this here without anything, nothing happens. So just as we intended. Then with the correct user and with a wrong pin, also nothing happens. And notice that here you cannot see the numbers I'm typing now because this is a different format in HTML, but I'm still using the 4 ones. So 1, 1, 1, 1, and now something should happen. And indeed, we get the index number of the JS account in the accounts array. So let's take a look at that array here. And indeed, the Jonas one is number 0, right? Now, if we logged in here as Steven, STW with 3333, and now we need to confirm that here. So STW again and 3333, hit enter, and then the result should be down here. And indeed, it is. So that's element number 2. So 0, 1, and 2. So that is correct. And so our splice here would now indeed delete the user. Okay, so let's see here what we did in the findindex. So just like before in find, we passed in a condition, so something that will return either true or false. And the findindex method will then return the index of the first element in the array that matches this condition. So for which this condition here returns true. So again, similar to find, but it returns the index and not the element itself. Now you might notice that this is actually similar to the index of method that we studied before. So index of, and then here we can pass in some value. All right. Now the big difference here is that with index of, we can only search for a value that is in the array. So if the array contains a 23, then it's true, and if not, then it's false. But on the other hand, with findindex, we can create a complex condition like this one. And of course, it doesn't have to be the equality operator here. It can be anything that returns true or false. Okay, and here we can simply check if the array contains this value or not, and if so, return the index of it. So both return an index number, but this one here is a lot simpler. And so now let's actually delete this element here. So this current user or the current account. And now let's get back here to our flowchart, which I closed for some reason. And so we just did this part. Now we also need to log out the user. So that just means to hide the UI. And so that's similar to what we did here, where we showed the UI. Now we want to set it back to 0. So down here. So hide UI, and here delete account. Okay, and then of course, as we reload the page, as I said before, the user will then be back, of course, because we do not persist this data anywhere. All right. Well, the UI is still there. Oh, and that's because we didn't change this here to 0. But anyway, let's still take a look at the accounts object in this moment. And we see that we now only have 3 accounts left. And the one of Jonas is nowhere to be found. So this means that it actually worked. Now we just need to fix this here and set it to 0. And we also, just like before, want to clear these fields here. So that's the same as we did before. So similar to this one. Let me just copy it here. And this one we can paste right here outside of the if statement. And then just copy these 2 inputs here. So close username and close pin. This is set to 0. And now this should actually be complete. So let's see. Well, nothing happened. So let's see here. Oh, okay. This is a bug that it just introduced here. So basically, before even reading the data from this field, I'm already setting it back to empty here. Okay, and so therefore, of course, nothing can work. So this needs to be after the if-else statement. All right, but it's still a good thing that these small bugs keep happening here so that I can fix them and show to you that everyone makes this kind of mistakes. So let's try it again, 1, 1, 1, 1. And now it's gone. And as I try to log in now as this user, you see that nothing happens and we get undefined down here. And that's because this user no longer exists now in our accounts array. Great. So one more feature implemented successfully. Now, there's just a couple of things I want you to note here. Both the find and findIndex methods get access to also the current index and the current entire array. So as always, besides the current element, these other 2 values are also available, but in practice, I never found these useful. And second, both the find and findIndex methods were added to JavaScript in ES6. And so they will not work in like super old browsers. But don't worry, there is going to be a lecture a little bit later on how to support all of these old browsers. So we're getting closer to the end of this section, but there are still a couple of array methods left to learn. And so in this lecture, we're going to look at the sum and the every methods. And to start learning about the sum method, let's look back at the includes method that we studied earlier. So let's log to the console here, movements.includes minus 130. And let's also log our movements array so we can see it. And so indeed, the value of minus 130 that we're testing here is in the array, and that's why we get true here. And so we can use the includes method to test if an array includes a certain value. Now, however, we can only really test for equality, right? So basically, includes here returns true if any value in the array is exactly equal to minus 130, right? And so again, this is essentially testing for equality. But what if we wanted to test for a condition instead? And so that's where the sum method comes into play. So let's say that we would like to know if there has been any deposits on this account. So in other words, we want to know if there is any positive movement in this array. So any number above 0. So how would we do that? Well, we can say movements.sum, and now we can specify our condition here as always. So the same callback function which has to return either true or false. And so a deposit is a movement greater than 0. So let's call this here any deposits and log it to console. And so indeed here we get true. So we have, of course, more than just one deposit here. But let's say we wanted to test if there is any deposit above 5,000. So easy enough, we can check if there is something above this value, and then it is false. Or we can check if there is something above 1,500, and so now it's true, because there is one movement here in that condition. And so you can see that these two methods here are kind of similar. The difference is that here it checks only for equality. So equality, but here we can specify a condition. All right. So basically this one here, we could rewrite it like this. So let's log it to the console here. So movements dot sum minus 130. So this would be exactly the same. And so that's why we also get true in this one. Now for equality, this doesn't make much sense. We could then simply use the includes method. But for the case we need a condition like this one here, or really this one, then the sum method is perfect for that. Okay? And probably if I would have named this method, I would have called it like any. But of course, that's not the real name, but that's really what it does. If there is any value for which this condition is true, then the sum method will return true. All right? And now let's actually use this sum method to implement our missing functionality, which is to request a loan to the bank. So we will do that right here between the transfer button and the close button. And the sum method will become helpful for this loan feature because our bank has a rule which says that it only grants a loan if there is at least one deposit with at least 10% of the requested loan amount. So that sounds complicated, but we will implement this here in a second. So button loan, add event listener, click, and this is now always the same as you can see. So starting by preventing the default action. So that's always going to be the first thing. And then let's take a look here at the user interface, because right now it is hidden. So you see that here we only have this one field. This field is called the input loan amount. Okay, so input loan amount. So that's the element with this long class name. So let's copy that actually. And so let's start by actually getting that amount here. So we already know we will have to convert this input dot value. Okay. And now we need to create our condition here. So first of all, that amount should be greater than 0. Okay. And now let's take a look here at our flowchart again. So this is what I was saying earlier. The loan is only granted if there is any deposit that's greater or equal 10% of the requested amount of loan. All right. So here we need now our second condition, which translates that. And so whenever we see or hear the word any, we can already know that it's probably a good use case for the sum method. So let me show it to you. So as always, we get the movements from the current account object dot movements, and now on there we call the sum method. So you already know by now how this callback function feature here works. So we get the current movement in the current iteration. And now here the condition is that movement needs to be greater or equal than 10% of the amount. So that's the amount divided by 10. Okay? Or we could also do times 0.1, and so that's exactly the same thing. So 0.1 here stands for 10%. And so let's keep it like this. Give it a save so that it looks nicer. And so, yeah, if at least one of the elements in the movements array has this condition, so is true, so basically is greater than 10% of the requested amount, then all of this here will become true. And so the sum method is perfect to be used in a condition like this. So when we need to test for something. Okay, so in case this is true, oh, and I closed our flowchart again. So in case this is true, then add a positive movement to the current data and update the UI. So that's easy enough. So add the movement here. So current account dot movement dot push, and then of course the amount that was requested. And then update the UI. And for that we already created our nice function which does all of the functionalities in one go. And so that's update UI, and we simply pass the current account into it. Okay, and that's it. Finally, let's also then clear the input field. So that value equals empty value. So we did that here and also up here. Okay, let's log in. And so you see my deposits, my largest deposit is 3,000. And so the loan that I can request can be maximum 30,000. Okay, because 3,000 here is 10% of that. So let me try something bigger, so something really huge. And so now nothing happened. And again, in the real world, we would then probably get some error message somewhere here at the top or so. But in this case, we're not going to do that. Let's just try 5,000 now. And so now, indeed, it appeared here in our movements. And also, as you see, our balance was updated. And also here, our total income. Okay, now let's request 50,000. And with this, you can now actually cheat. You can always create a little bit of a larger number. So now I can even request 500,000. And so that's cheating our algorithm, which is way too simple. But of course, this is just for testing purposes. All right. So that's how the sum method works. I hope that makes sense. And so let's now actually go back here and talk about the close cousin of the sum method, which is the every method. So let's write here sum and every. So again, the every method is pretty similar to the sum method, but as you might guess, the difference between them is that every only returns true if all of the elements in the array satisfy the condition that we passed in. So in other words, if every element passes the test in our callback function, only then the every method returns true. And that's why the method is called every in the first place. So let's test it out here now. So let's log to the console movements.every, and then with the same condition. So let's essentially check if all of our movements here are deposits. And well, indeed, they are not. And that's why we get false. However, we do have one account which only has positive movements. So let me show that to you. That's account 4. So account 4, all the movements are positive. So let's check it out now. So account 4, and then the same condition. And every is not a function. And that's, of course, because we are still missing the movements array. And now it is true. All right. And so that indeed proves that the every returns true if all the elements in the array satisfy this condition. Because in this movements array, all of the values are, in fact, above 0. Okay? So that's how the every method works. And I think it's quite straightforward, isn't it? And now to finish, there is one more cool thing that I want to show you. So up until this point, we have always written the callback function directly as an argument into our array methods, right? However, we could also write this function separately and then pass the function as a callback. So let's say separate callback. And so we could do this. So let's call deposit to this function. All right. And so this function here is exactly the same as these ones. But as I just said, there is no reason for them to being directly written here in all of these array methods. We could simply write them like this, and then all we would have to do is to call movements.sum, for example, and then deposits or deposit. And now we could reuse the same function for all kinds of different methods that require callbacks with a true-false condition. So that could be every or filter as well. Okay. And so here is the result of these 3 operations. And so here we get the expected results. And all by reusing this same function. Then if we wanted to change the function, all we would have to do is to change it here in one place. And then all the results would become different according to that. So in practice, that's something that we do sometimes, because this is of course better for the dry principle. So don't repeat yourself. That's always important, and it is important here as well. But anyway, with this small detour that we did here, let's now move on to learning about 2 more array methods. The next 2 array methods that we're going to learn are the flat and flatMap methods. And thankfully, these are very easy to understand. So let's go. So let's say that we have an array with some arrays in it. So essentially a nested array. So let's say 1, 2, 3, and then another array here, 4, 5, 6, and then even some values like this. So this is perfectly normal. But what if we wanted to take all these elements in the subarray and put all of these together in just one big array, which contains all the numbers here from 1 to 8? Well, that's pretty simple using the new flat method. And they say new because flat and also flatMap were introduced in ES 2019. So they are pretty recent. And one more time, they will therefore not work in super old browsers. Okay, and actually that's it for the flat method. So no callback function, just like this. And we get indeed our full array from 1 to 8. So this removed the nested arrays and flattened the array, which is why the method is called flat. So very nice, very simple, and no callback function this time. Okay, but now let's say that we have an array which is even deeper nested. So let's call it R deep. And so this one right now has only like one level of nesting. But let's say that these two here are in their own array still. And maybe these two here as well. So now we have an array inside an array inside an array. So let's see what happens when we flat this one. And we got the same result, but that's because I made this mistake. So we need to flatten R deep. And so now you see that we get this result, which still contains the two inner arrays. All right. So this means that the flat method only goes one level deep when flattening the array. So this 3 here was inside the first level of nesting, and so therefore it was taken out and is now in the main array, but then we still have this nested array in there. So we can fortunately fix that by using the depth argument. So right now, basically flat is running with the 1 here as the depth, and so if we run it with 1, which is the default, then we get this, but we can go 2 levels deep. And so now we get the same result as before. And that's because it now goes even into the second level of nesting and also takes the element out of that array. All right. So that's how flat works, but this example is not really that useful. And so let's go back to the bank accounts. So let's say that the bank itself wants to calculate the overall balance of all the movements of all the accounts. So how would we go about solving this problem? Well, first of all, we have all these movements stored in arrays. And these arrays are inside the objects in the accounts array, right? So in this array that we have been using, so accounts, so that's the one. So this is where we have our movements. And so the first thing to do is to take them out of here and put them all into one array. So how would we do that? Well, let's create a variable here called account movements. And so we could do accounts like this. And then what we want to create is a new array, but with the same length, which only contains these movements array. So that's what I was just saying, right? And so for that, we can use the map method. So in each account, take the account dot movements and so return that value into the new array. All right. And so now we have this array, which then in turn contains the arrays of all the movements. And so you see that now we actually have a nested structure here. So an array which contains other arrays. And so probably you can see where I'm going with this, because now I want an array which simply contains all of these values just in one array. So let's call this one all movements. And so it's going to be account movements dot flat, right? And we have only one level of nesting, and so there's not even a need for any parameter here, so for any argument. So now we get this nice array of the length 29 with all of these movements. And now all we have to do is to add them all together, which is pretty easy at this point, right? So let's call this one overall balance is equal to all movements dot reduce. And here we get the accumulator and the current movement. And we return accumulator plus movement, and we start with 0. So I'm doing this all very fast here because I already explained all of this multiple times at this point, right? And so here we get the final result of adding up all of these values that were originally, as we started, in the separate movements arrays that were in turn inside of the account objects, right? And of course, we can make this here a lot more beautiful. So instead of doing all of this separately, as you already know, we can use chaining. So we start with this here. So building a new array out of the array of account objects. Then we flat that result, and then we add it all together. So like this. And then we log it all to the console. And this is then unnecessary. And actually, I will just delete all of it. Give it a save. And here we get the exact same result. Now, it turns out that using a map first and then flattening the result is a pretty common operation. So that's exactly what we have here. So first we map and then we flat that result. So that's exactly what we have here. And so to solve this, there is another method that was also introduced at the same time, which is flatMap. And so flatMap essentially combines a map and a flat method into just one method, which is better for performance. All right. So let's do this one here again, but this time with flatMap. So actually we can just copy it, and here I'm going to call it just a 2. And so here we will now use flatMap instead. And since flatMap also does mapping, it needs to receive exactly the same callback as a map method. Okay, so this is essentially a map method. All it does is, in the end, it then flattens the result. And so you see here the result is the same. Now just notice that flatMap here only goes one level deep, and we cannot change it. So if you do need to go deeper than just one level, you still need to use the flat method. So anyway, keep these two in mind whenever you find yourself in a situation where you have nested arrays and need to work with them. And believe me, that happens more often than you think. And I believe that even in the course of this course, there is going to be another situation. So we're almost finished with this section and with our application. But one feature that is still missing in our application is the ability to sort or movements. And so in this lecture, let's talk about sorting arrays. Now, sorting is a much discussed topic in computer science, and there are countless algorithms and methods of sorting values. And we might actually talk about this a little bit later in the course. For now, though, we're simply going to use JavaScript's built-in sort method. And let's start here with an array of strings. And let's call it owners. So Jonas, Zach, Adam, and Martha. Okay. And now all we need to do is owners dot sort. Okay. And so indeed, we now get our array here nicely sorted. So alphabetically from A to Z. So this works indeed just as expected, right? Now this actually mutates the original array. So if we take a look at owners now, you will see that it also is now mutated. Okay, and so we have to be very careful with this method. So this is with strings. Now let's try it with numbers as well. So let's use our movements array here one more time. So I will start by logging it to the console so we can see it. And then let's also log movements dot sort. So give it some more space here. And if we take a look at the result here, this time the result is not really what we are expecting, right? These numbers are not at all ordered in any way, are they? And the reason for this is that the sort method does the sorting based on strings, all right? So that might sound weird, but that is just how it works by default. So basically what it does is to convert everything to strings, and then it does the sorting itself. And if we look at the result as if they were strings, then the result actually makes sense. So the minus here, you see, always comes first. Okay, so first you have all the minuses here, and so that's basically alphabetically the first string that occurs. And then afterwards, you have this one which starts with 1, before this 4, and then before this 6. So these three are alphabetically ordered if they were strings. And the same here. So you have 1 first, then 2, then 3, then 4, and then 7. So again, if they were strings, then this result would make sense. But they are not strings, and so we have to fix this. And in fact, we can fix this by passing in a compare callback function into the sort method. So this here does not work. Let's get rid of it. And so let's write movements.sort, and we need to give it a callback function. And this callback function is called with 2 arguments. And let's simply call them A and B. Okay. And these 2 parameters here are essentially the current value and the next value if we imagine the sort method looping over the array. However, in order to understand how the compare function works, so how this callback function here works and how we have to write it, let's just think of A and B as simply being 2 consecutive numbers in the array. And it doesn't matter which ones. So let's simply take these 2. So 450 and 400. Okay? So let's just compare these 2. Now, in our callback function here, if we return less than 0, then the value A will be sorted before value B. And the opposite, if we return a positive value, then A will be put before B in the sorted output array. Okay, so let's use that in practice to sort the movements array in ascending order. And first, let me just write what I just did here. So if we return something less than 0, then A will be before B. But on the other hand, if we return greater than 0, then B will be before A. Okay? And so we can use this knowledge to sort our movements array now in an ascending order. So ascending order means that we want to go from small to large numbers, right? And to make this easier to understand, let's analyze the 2 numbers that we have here. So we have 450 and minus 400. And so if we want to sort these 2 in an ascending order, then we need to switch them. So this is A and this is B, right? But now we want to switch them to make them in an ascending order. So what we want here is B and then A. So BA, right? And so therefore we need to return something that is greater than 0. Okay, because that's the rule how the sort callback function works. So again, in the case basically that A is greater than B, which is what we have here, then we want to return something that is greater than 0. So let's write that. So if A is greater than B, return, and let's say 1. And the number here doesn't really matter as long as it's greater than 0. And else, or actually let's write it like this. So if B is greater than A, then return something negative. So just minus 1. Okay? And that's actually it. So let's log then the movements again here to the console, because here we are mutating the array, and then at this point it is already the mutated version. And now as we see here, the array is now indeed sorted in an ascending order. All right, and so that is because basically the sort method keeps looping over the array and applying this callback function here until everything is in an ascending order according to the rules that we established here. Okay, so returning 1 here basically means to switch the order, and let's write that here. Switch order and keep order. So maybe that makes it also a bit easier to understand. So if we come back to one of these examples here, so let's say we have A and B 200 and 450. So in this case, we want to keep the order, right? And so therefore, that's the case in which we return something less than 0. So that's what we have here. And maybe it's easier to read like this. So A less than B, but of course it's the exact same thing. And then here again with our original example, this first one is greater, so the order has to be switched. And so here we have that situation where A is greater than B. Now if we wanted to do it the opposite, so sorting in a descending order, we would simply do it exactly the other way around. So all we would do is to return -1 in this case and return 1 in this case. And so now the array is nicely sorted the other way around. So let's write that here. So ascending and descending. Let's also log the movements here. And great. So this works beautifully, and it's also going to work for strings, and you can try that out yourself if you want. Now, if we are working with numbers, then we can actually simplify this a lot by simply using some simple math. So let's take a look again here at our condition. So we already know that if A is greater than B, then A minus B would always be something positive, right? And the same here with A less than B. So if A is less than B, then we know that A minus B is always something negative. And something negative is exactly what we want to return here, isn't it? And so what we can do is take this and improve it dramatically. Because in fact, we don't need any of this. All we need is to say A minus B. And that's it. Let's check the result. And it still works the same. So let's recap what we did here. So again, we already know that if A is greater than B, then this will be a positive number. And so here we then return that positive number. It doesn't have to be exactly 1, just something greater than 0. Now, if it's the other way around, if A is less than B, then this operation will always be a negative number. And so therefore, then something negative is returned just as -1. But again, it can be any number. And by the way, if we return 0 here, so in case these two values are the same, then their position simply remains unchanged. All right? So let's do the same here. And so here it is the opposite. So B minus A. And as always, keep in mind that we are actually returning this value here. But we don't have to write the return because we're using an arrow function. So you see, it still works the same. All right. And this is basically most of what you need to know about sorting arrays with numbers. Now, if you have a mixed array, like with strings and numbers together, then this is not going to work. And I advise you to simply not use the sort method in these cases anyway. And that's because there's not really a point in doing so. But anyway, now that you know how the sort method works, let's go back to our application and implement it there. So let's first see in the demo version what I mean. So down here we have this sort button. And so this sort will basically sort these movements. So as we click the button, it will sort them in this descending order, which actually is an ascending order because remember, we are starting to display these movements here from the bottom up. Okay? Then as we click it again, it goes back to normal. So as we keep clicking, it orders and goes back to normal. And so let's implement that now. So we can give us some more space here. And now we will actually implement the sorting functionality right in the function that displays the movements. Okay, so let's first implement the sorting itself, and then after that we will implement the clicking on the button. So that's right here. So display movements. All right. Now what we're going to do here is to add a second parameter, which is the sort parameter, and by default we will set it to false. And now depending on this parameter, whether it is true or false, we will then order our movements or not. So sort the movements or not. And of course it is false by default because, well, by default we do want to show the movements just in the order they appear in the array. But then as we click that sort button, we will then call this function display movements with sort set to true. So let's now create a new variable called movements here. And this variable here, we will define it conditionally. And actually we cannot call it movements because that's already the name here of the parameters, right? So let's just call it movs, all right? And again, we will define it conditionally. So we say if sort, and so that's if sort is true, then we actually want to sort the movements. So the movements array that we get here as an input. So movements, but now we cannot do this. And that's because, keep in mind that the sort method will then order the actual underlying array. So the actual movements array as it is in the account object. But that's not what we want at all. All we want is to display a sorted movements array, but we do not want to sort the original underlying data. So what do we do here? Well, we simply take a copy of the movements array and sort that. And so that's what we use now slice for. And this is one of the situations that I was telling you about earlier, where we need to actually create a copy using the slice method and not the spread operator. Because here we are in the middle of a chain. And so we want to keep going after this. And so it's a lot better to simply use the method here so that we can then simply chain the sort method onto that. And now all we need here is our compare function. And now remember how in the user interface, so in our application, how the movements appeared in a descending order. However, that is because we start to display the values from the bottom up. And so actually we want to now sort this array in an ascending order. And to do that, remember we do A minus B. So I explained before why it works this way. Okay, but now if sort is false, so that's the default value, then movs should simply become movements. Right? Let's get rid of this comment here. Give it a save. And now here, of course, we then need to use that movs that we just created. And with this, we have essentially adapted our display movements function to support sorting. And again, we did that by allowing a second parameter, which is an optional parameter called sort. And then if sort is set to true, then the movements that we're going to use to display them will be sorted like this. And if it's set to false, then simply the regular movements as they are passed in will be displayed. And now all we need to do is to call this function here with sort set to true whenever the user clicks that sort button. So that button is called button sort. And so let's now create our final event listener or event handler here. So button sort add event listener. And as always, we start by preventing the default, so you can get used to this. And then here we want to call print. And then here we want to call display movements. And of course with current account dot movements as always. And then the second parameter we will set to true. So that's the sort parameter. And if we ever are in doubt, again in VS Code, it nicely shows us what we can pass into the function. So movements and sort. Now this is not yet the 100% working solution, and let me show you why. So, as I log in, let me almost remove this here. So let's click now the sort button, and beautiful, that worked. So the movements are now indeed sorted, but now if I click the button again, it will not go back to normal, right? And how could it? We never told it to do so. So let's find a way of solving this. And we will solve this by using a state variable which will monitor if we are currently sorting the array or not. Okay, so that variable needs to live outside of this callback function so that its value can be preserved after clicking this button here, right? Because as you know, this function here is executed each time that we click the sort button. And so if we defined a variable here in this function, then it would be created newly each time that we click that button. And so we want to preserve that sorted state throughout all the clicks. So we start with this state variable set to false. And so that's because in the beginning our array is not sorted. So sorted is false. And so if it is false, then here this should be true. So we then want to actually sort the array. So basically here we want the opposite of sorted, right? And so that's where our not operator comes in handy. All right, so we're doing the opposite of sorted. When sorted is false, then we want to sort it. So we need true here. But if it is already sorted, then we again want the opposite, and so then sort should be back to false. Now the only thing that's missing is to actually flip this variable. Okay, and so for that we do sorted equal the opposite of sorted once again. And so this is what then allows everything here to work. Otherwise, even as we would click, this sorted variable would then never change. And so with this, each time that we click, we change sorted from true to false, then from false to true, and so on and so forth. So let's try it now, finally. And yes, great, that works beautifully. And so our job here is done. And in fact, this application is now complete, at least for this section. So great job, congratulations for reaching this point, for finishing this application. This is really an amazing achievement, and you can pat yourself on the back for making it this far. Now, there is still 1 or 2 array methods to learn, and so let's do that in the next video. The last thing that we're going to learn in this section is how to programmatically create and fill arrays. So far, we have always simply created arrays like this, right? So basically writing them out by hand, literally. So just like this, or maybe we might have done it also like this. So using a new and then the array constructor, and then passing in all the numbers here as arguments, and then that also creates this array, right? Now, in these cases, we basically already have our data. So, for example, 1, 2, 3, 4, all the way to 7. So that's the data that we already have. And so therefore, we could then manually create these arrays. However, we can actually also generate arrays programmatically, so without having to define all the items manually. And there are many situations in which this is necessary, and there are also multiple ways of doing it. And the easiest one is to again use the array constructor function. So let's create a new array here like this. And then I will pass in only one argument, 7. So what do you think is going to happen? Well, we might think that this is going to create an array with only one element, number 7, right? But actually it doesn't. Instead, it creates a new array with 7 empty elements in there. And it simply contains nothing. So this output is very weird indeed. And the reason for that is this weird behavior of this array function, which does it so that whenever we only pass in one argument, then it creates a new empty argument with that length. So if we don't know about this special particularity of the array constructor function, then this can lead to weird errors. Okay? Now, also, we cannot really use this X array for anything. For example, we cannot call the map method on it to now fill it up. For example, we might want to do this. So map, and then in each element, we might simply want to put something there, like a 5. But then you will see, well, actually we need to log it to the console. But you will see that nothing happened here. So this is not really useful except for one thing, because there is one method that we can call on this empty array, and that is the fill method. So that's a new method that we haven't studied yet, but it's very straightforward. So let me show it to you. So that's x.fill, and then all we need to do is to pass in a value, and it will then fill up the entire array with this specific value. Okay? And this does actually mutate the underlying array. So we can just change it there, and then simply log the entire thing to the console here. So this doesn't work. Let's take it out. And now we get this array full of 1s. But let's actually turn this off so we can experiment a little bit more with fill, because this method is actually a little bit similar to the slice method. So besides this value that we want to fill the array with, we can also specify where we want it to start to fill. So let's say only at index 3. And so we also can specify a begin parameter, and then it only starts at index 3, which is this one. So it will then fill it up until the end, unless we specify an end parameter, just like in slice. So let's say 5, and also just like in a slice, the final index here is not going to be included in the array. So just these two here are filled up. And of course, we can also use the fill method on other arrays. So it doesn't have to be an empty array. Let's say we actually define this here as an array. Okay, and then we can also fill that array. So let's say r.fill, let's fill it with 23 at position 4 to 6. And again, it will mutate the original one. And so you see that we put these 23s in these two positions. So from 4 to 6. Let's say from 2 to 6 to put some more in there. Okay? So this is the fill method plus empty arrays. So empty arrays plus fill method. And with this, we created an array programmatically, so without actually having to write it down manually, right? So let's bring this part back also to see it. So it's an entire new array that we here just created with our code. And indeed, the fill method can be very useful sometimes. However, what if we actually wanted to recreate the array from our first example? So what if we wanted to create this R array programmatically? Well, for that, we could use the array.from function. So that's array.from. And this is how we use it. And this is actually something completely new. And we didn't see this before. So here we are not using the from here as a method on an array. Okay? Instead, we are using it on the array constructor. So that's why it's array.from. And this array here is exactly the same as this one. So this function. So again, array here is a function. And then on this function object, we call the from method. So that sounds confusing, but we will make more sense of it in the object-oriented programming section. But anyway, into this function here, we can first pass in an object with the length property. So let's set it to 7. And then the second argument is a mapping function. So it is exactly like the callback function that we pass into the map method. So to start, let's also programmatically recreate this array here of 7 ones. And so let's write a callback function here. And in this case, we don't even need any arguments, but we still have to write the function. So let's write an arrow function here, which will simply return 1 in each iteration. So no arguments, no current element, no current index, and nothing. So all we want to return is a 1, and that will then put a 1 in each of the array positions. So let's call this one here y, and then log it to the console. And indeed, we get here the exact same result that we had before. But in my opinion, this is a lot cleaner than using this weird new array behavior then and together with the fill method. So in my opinion, this is way nicer. But anyway, let's now take it one step further and actually create this initial array from 1 to 7. So array.from length equals 7, and then our callback function. And as always, we get access to the current element. So let's call it current first, and then the current index. And so the index will vary between 0 and 6. And so all we have to return from this function is I plus 1. Okay? So again, this callback function here is exactly like the one in a map method. So you can simply imagine that you're using this as a callback function in calling the map method on an empty array. Okay? And so as always, we get access to the current element and the index. And so adding 1 to the index will then give us values from 1 to 7. So z, and yeah, here we go. Now remember how earlier I used a variable like this, so an underscore, which means a throwaway variable. And so this is another use case for using this convention, because we do not need this current value at all. But we still, of course, have to define something as the first parameter, because the index that we need is only the second parameter. But to denote that we are not using this current element, we simply write an underscore. Okay, and then other programmers will also understand this convention and automatically know that we don't use this parameter. Okay, so this is how we create an array programmatically. And I hope you can see all kinds of different use cases for this. For example, you could create an array with 100 random dice rolls. So maybe you want to try that out on your own. And that is actually one of the assignments that I have later here for this section. So there's going to be a couple of exercises, and this will be one of them. But you can try it out immediately if you feel like it. So try array.from to generate an array with 100 random dice rolls. Okay, see if you can do that. But anyway, let's now move on and see a more real use case of the array.from function. Now, this array.from function was initially introduced into JavaScript in order to create arrays from array-like structures. So remember how I talked about so-called iterables before? So things like strings, maps, or sets, they are all iterables in JavaScript. And so they can be converted to real arrays using array.from. Okay? And that's the reason also for the name of the function, because we can create arrays from other things. All right? Now, besides these obvious iterables that I just mentioned, like maps or sets, another great example of an array-like structure is the result of using query selector all. So maybe you remember that query selector all returns something called a node list, which is something like an array which contains all the selected elements. But it's not a real array, and so it doesn't have methods like map, for example. But it's not a real array, and so it doesn't have most of the array methods like map or reduce. So if we actually wanted to use a real array method like that on a node list, we would first need to convert the node list to an array. And for that, array.from is perfect. So let's do something here now. And let's say that we do not have the movements of our application here stored in an array. So let me show that real quick. So again, let's pretend that we only have these values, so all of these movements only stored here in the user interface, but we do not have them somewhere in our code. So we don't have an array containing these values. But now, let's say we want to calculate their sum. And so therefore, we need to somehow get them first from the user interface and then do the calculation based on that. So let's create a variable called movements UI. So the ones that we get from the user interface. So array.from, and now here the element that we want to convert to an array. And so that's going to be document.querySelector all, and then it is the movements value class. I'm going to show it to you in a second. So movements value. So in our HTML, we can see that exactly this is where the value itself is stored. And so that's what we want to get. So these numbers, right? And so we are selecting all of the elements that have this class. All right. So let's just start by checking it out. Movements UI. But now we only get 2 elements here. And so that's the one that by the time we load this script here are already in the user interface. So it's this and this one here. So not the 7 that are loaded from the account object. So it's not going to be these 7 here. Okay. So if we wanted to actually select exactly these elements, we would have to do this code here on some event handler. So let's do that actually. Let's simply perform this action when we click somewhere here. Let's say here on this balance label. So it doesn't matter where we click. So that is called the label balance. So we can attach event listeners to every object. Okay, it doesn't have to be a button. So I think we never did this actually. But let's see what happens now. So let's log in again here. And again, remember that we are doing this so that we can now read these 7 movements from the user interface as we click here. And indeed, now it worked. So now we get these 8 movements here. And you see that indeed it is these values that we see now on the screen. All right. But now let me also show you that we cannot call the map method on it, because the map method would be useful to now actually get just the number. Because you see that here we also have this euro sign, and so we need to get rid of that. And so the map method would be perfect for that. So what we would like to do is, let's just do it here for now. We would love to take the current movement. All right. And so in this case, the movement here, well, let's just call it element actually, because right now it is a DOM element. So we would take this movement, which is, remember, one of these elements here. And so from this element, we need to take the text content. And then we also want to replace the euro sign with nothing, basically. So I'm using the emoji picker here again on the Mac. But you can just get the symbol from your text up there, so from the code we already wrote. And I want to replace it with nothing. But now you will see, as we try this again, that it's not going to work. And in fact, it does actually work. And that's because I was saying it wrong. Of course it's going to work, because this one here is already a real array at this point. So we created this movements UI using array.from, and so of course it is going to work already. It would not work if we did it directly on the result of the query selector all, okay? So sorry for that mistake. So it did indeed work already. But we can make this even better. First, of course, we need to convert this to a number. But that is not the point here, actually. So the point is that we can use now the second argument of the array from a function here, which is, remember, the mapping callback. And so basically, we can simply put this entire callback right here as the second argument. Okay, and now this movement UI array is already the final array as we see it here. So let's just check that out and then make really clear what just happened here. So again, and as we click here, we get indeed all the numbers that we have here. So let's recap. We used array.from to create an array from the result of the query selector all, which is a node list, which is not really an array, but an array-like structure. And that array-like structure can easily be converted to an array using array.from. And then as a second step, we even included a mapping function, which then transforms that initial array to an array exactly as we want it. So basically converting the raw element to its text content and replacing the euro sign with nothing. Okay, and so then in the end, we end up exactly with the array of numbers that we intended. And by the way, I'm not sure if I mentioned it earlier, but there is another way of converting this here to an array. So let me grab it here. So movements UI2, and then we can actually spread the result of this query selector all into a new array as well. So this also creates the array, but then we would have to do the mapping separately. And so actually I prefer this. So to me, the array.from function was a great addition to JavaScript in ES6. Okay, and that's actually all I had to tell you here in this video. So that was the last couple of methods and functions that we learned about arrays. And indeed, We learned a lot of methods in this section, right? Now, keeping all of them in your mind to solve different tasks is, of course, a very hard thing to do. And so to make sense of all this mess, in the next video, I will help you decide which array method you should use in each situation to solve different problems. So I did the math, and since the beginning of the course, we have studied exactly 23 different array methods. And that's really amazing. And not just because 23 is my favorite number, but because that means that you can now do everything you can imagine with arrays. Now, the problem is that choosing between 23 different methods is not always easy. And especially when you just started learning about them, right? So probably in your mind right now, there is a big confusion between all these methods and about which one to use when. So to help you out with that, I created this summary lecture with all the 23 array methods. And I believe that the best way to figure out which method to use in each situation is by starting to ask the question, what do I actually want from this method? So do I want to mutate the original array, or do I want a new array? Do I maybe want an array index, or do I want to retrieve an entire array element? Or do I want to know if an array includes a certain element? Or maybe I just want to get a new string to transform the array to a new value, or simply to loop over the array? Well, these are a lot of different scenarios, and by asking exactly these questions, we can now categorize the methods and then easily choose between them. So this is kind of a framework that I developed, and so let me go briefly through all of these different scenarios with you. So these are the methods that mutate the original array. So if we want to add an element to the original array, we can use push or unshift. So we already talked about all of these methods, so of course I will not explain them again. This is just a reference for you to keep. Now anyway, if we want to remove from the original, then we use either pop, shift, or splice. And finally, we also talked about 3 other methods that mutate the original array, which is the reverse, sort, and fill method. Okay, so keep in mind that you have to be careful because they do change the underlying array that we're working with. And that many times is not what we want. So if instead we want a new array, then we can use one of these methods. So if we want to calculate one array from the original, then we use map method. And this one we use all the time as it loops over the original array and creates a new one based on that. We can also create new arrays by filtering for a condition or by taking a slice of the original array. We can also concatenate 2 arrays and create a new array based on that. And finally, we can flatten the original array using flat and flatMap. Next, sometimes we need an array index. And for that, we have the index of and findindex methods. Now, the difference between them is that findindex can basically search for an element in the array based on a test condition that we provide in the callback function. But besides that, they are pretty similar and both give us the index of a certain element in an array. Now, if we actually need the array element itself, then we use the find method. And so this one again is based on a test condition specified in a callback function. Next up, sometimes it's very important to know whether an array includes a certain element or not. And for that, we have includes, some, and every. So with includes, we can simply test if an array contains a single value, while on the other hand, with some and every, we can specify a condition based on a callback function. So some is going to return if at least one of the elements in the array satisfies the condition, and every only returns true if all of the elements satisfy the condition. So these 3 methods all return Boolean values which is very helpful in a condition. For example, in an if-else statement. Okay, so that's where you many times will use one of these methods. Next up, sometimes we want to transform an array into a string, and then we use the join method. Or we might want to reduce the entire array to just one value. And as we already know, for that we use the reduce method, just as we studied in this section. So in the reduce method, we use an accumulator, which is like a snowball, to boil down an entire array to just one single value. And that value can be of any type. So it can be a number, a string, boolean, or even an array or an object. All right. And so in fact, we could replace some of these methods that we have here with a reduce. Now, if all we want to do is to just loop over an array without producing any new value, we use the for each method. So remember, this one does not create a new array, and in fact, it doesn't create any new value. All we do in the for each method is to basically just do some work, but not produce a new value. All right, and that's it. That's an overview of all the 23 methods that we can use on arrays. And it might be a good idea to somehow keep this overview handy. For example, print it out on a paper, or just store it somewhere on your computer. Anyway, now all there's left to do in this section is to complete the final coding challenge. So let's do that right in the next video. Now, before we go to that coding challenge that I just promised you, let's actually practice these array methods a little bit more. And again, that's because I had many people actually request yet another practice lecture of these array methods. And so you asked for it, and so here goes that lecture. So again, here you can already see the next coding challenge, but let's for now focus a bit more on some array exercises. And of course, we're going to continue working on our accounts examples. And the first exercise I want to do here is actually a very simple one, in which all we want to do is to calculate how much has been deposited in total in the bank. So in all the accounts across the bank. So let's call that bank deposit sum. And so, as always, let's take our accounts variable, which is that array which contains all the four bank account objects. Now, the first thing that we need to do here is to somehow get all these movements that are in these different objects all into one big array, so that we can then from there filter the deposits and then add them all together, just like we have been doing many times throughout this section. So let's use the map method here, because we basically want to create a new array out of the accounts array. But now we want to create an array which only has all the movements. And so, as you know already, whenever we want a new array with the same length as the previous one or as the original one, then we use map. And our callback function here, again, each account is called like this. And then all we want to take out is account dot movements. And let's start by immediately taking a look here at this variable. And of course, missing the log here. And indeed, we get an array of arrays. And here are all the different movements. Now, how do we get all of these values out of the arrays and into the main arrays? So whenever we have an array of arrays, how can we basically remove all the values into the parent array? Well, remember that for that, we can use the flat method. So just like this. And now indeed, we got a big array with all of the movements that we had previously. However, I hope that you remember that we can even simplify this here even further. So this map and flat because as it turns out, it's very common that we want to do these two operations at the same time. And so that's the case here. And so instead of map, we can simply use flatMap like this. So that will apply or map callback function and then flatten the result. And so you will see here that the result looks exactly the same. And now all we need to do is to filter for the deposits. So basically for the positive values. And so this is nothing new at this point, and the same for now adding them all together. So we have done that many times before. So let's just write it out here as we already know how it works. And here we go. So the result is 25,180. And let's say that they are all in the same currency. So all dollars or all euros. So this part here was the same as we had done before. The only trick was really this part here. So getting all the different movements array out of the accounts array and then putting them in one flat array so that we could then filter and add them all together. Let me just add here a number. So that was exercise number 1. And now in exercise number 2, I want to count how many deposits there have been in the bank with at least $1,000. So let's call this here num deposits 1,000. And there are actually 2 ways of doing this. So I will start with the way that is probably easier, but then after that, I will actually save the same problem using the reduce method. So many people have asked me for advanced use cases of the reduce method because it is probably the most difficult of all of them. And so therefore, I want to show you how we can basically count things using the reduce method. But again, let's start with the easier solution here. And so if we want to count the deposits, basically now we have to do the same thing as we did here, right? So we have to take all of the movements and put them all into one array. And let's log that here already. And here it's accounts. And so you see we have a similar result to previously. And now what we could do here is to filter for movements greater than 1,000, like this. So movement greater than 1,000, which leaves us only with these. And then from that, we can simply take the length, right? And so this will then return 5. And indeed, this shows us that we get 5 deposits over $1,000. Let's say at least, so greater equal. All right, so that was one way of doing it. Let's comment it out because as I mentioned before, I actually want to show you how we could do the same thing using reduce. So let's get rid of this part because the flat map, of course, we still need that. We still need that array with all the values themselves. Now, okay, so you already know that the callback function of the reduce method always has as a first parameter basically the accumulator. So that's like the snowball onto which we want to accumulate a certain value. So here that is the sum, which we started at 0, and then onto that sum we keep adding the current element, and then basically in each iteration we returned that entire new value. So the previous sum plus the current value. Okay, so again, this here is the accumulator, which is like the snowball onto which we keep adding our snow, which in this case here was the sum. But now in this case, our snowball, so our accumulator, will be the number of movements that are greater than 1,000. All right, so let's call that the count, and then here again the current. Then here we're going to have the function body, and again we will start counting at 0. So this initial value right here is just like having any value outside of a loop where we keep storing a new value. And that new value might very well be a counter that we only update on a certain condition, which is exactly what we're going to do now. So we will say that whenever the current value is greater or equal than 1,000, then we want to return the count plus 1. And otherwise, we just want to return the count. So give it a save, and here we get our result. I think it was 5 previously. Let's just take a look at the array itself by simply logging it to the console here like this. Or we should probably even do this to actually see the whole array. And you see that it is indeed 6. So before it was just 5 because I had it like this. And so you see there is one movement with 1,000, and so then it is only 5. But what matters here, and let's get rid of this. So what matters is that our reduce function here works. So we can even use reduce to basically simply count something in an array. So what's important to keep in mind is that we have this value here outside. So this accumulator, which we can use to reduce the array down to anything that we want. And in this case, it is a counter, but it could really be anything. And we will actually do something even more sophisticated in the next example. But for now, I want to bring your attention to this part here of the code. So this adding 1, right? So you know that there is an operator for simply adding 1. So let me duplicate this here. Then I will comment it out. And again, you know that we can simply use plus plus here like this, right? Or at least we think so, because now as I reload, we are back to this being 0. So why do you think that is? Well, there is actually something that I didn't tell you about the plus plus operator. And so I thought that this was a good opportunity to maybe clear that up. And for that, let's simply do a very simple example down here. Let's say let a equal 10. And then let's log to the console a plus plus. And so again, you see that a is actually still 10, even though we used this plus plus here. So why is that? Well, the plus plus operator does actually increment the value, but it still returns the previous value. So if we now log the a again here, you will see that now it is indeed 11, right? So the plus plus operator did its job here, but the thing is that when we use it like this, it will still return the old value, which here was 10. All right, and so the same thing happened here. So we did count plus plus, which then increased the value from 0 to 1, but the result of this expression here is still 0. And so 0 was returned here to the next iteration, and therefore, in the end, we will always have 0. So like this, it's impossible to increase the value to 1, 2, 3, 4, 5, and 6. So this is actually something really important to understand about the plus plus operator, and which I didn't make really clear before. Now, fortunately for us, there is an easy solution, because we can simply use the so-called prefixed plus plus operator. So we can write it before the operand, so plus plus a. And so now the result of this here should already be 11. So both of these should now be 11. And indeed, they are. And so if we do the same thing here, then that will now finally increment or counter here, and we are back to seeing 6 as our result here. So let me keep this one here actually just as a reference, again, because I didn't talk about this before. All right. So that was exercise number 2. And now let's go to exercise number 3, which will be an even more advanced case of the reduce method. And in this one, what we're going to do is to create a new object instead of just a number or just a string. Because why not? So we already know that reduce boils down an array to just one value. And so that value might very well be an object. It could even be a new array as well. And in fact, we could use reduce to replace many of the other methods that we have. So reduce really is like the Swiss knife of array methods. We could use it for everything. Okay, and with that being said, let's get started on this exercise, of which the goal is to create an object which contains the sum of the deposits and of the withdrawals. So basically we want to calculate these two sums all at the same time, all in one go, using the reduce method. So let me call this one sums. And then we have to start again in this way. So we need to get all of our movements into just one array. So I'm just copying that. And then here comes the reduce method. So here the first element, as always, is the accumulator, which again I will just call sums. And then the second one is the current value. Here we will actually need a function body to write our code. And then we need the initial value of the accumulator as always. And as I was saying, the goal of this exercise is to create an object. And so our starting point then of course also needs to be an object. And this could be an empty object just like this, or we could of course also already start filling it. So let's say that we want to start with deposits of 0 and withdrawals at 0 as well. Okay, and now here in our function body, we can simply basically ask if the current value is a deposit or a withdrawal. And once again, we do that by checking if the value is greater or below 0. So if it's greater than 0, and here again using the ternary operator, so if it is, then we want to add the current value to the deposits. So to this value here in our object, right? Now here in this callback function, what actually is this object here? Well, it is simply sums, which is our accumulator, right? Because this here is always the initial value of that accumulator, so of this variable. So we can access the deposits on sums dot deposits, and we can then add the current value onto that. And if not, so if current is below 0, then we can add it to the withdrawals. Okay, now we're actually not yet done here, because remember that in an arrow function, the value is only automatically, so implicitly returned when we don't have a function body with curly braces. But right now we do here, right? And so therefore we have to explicitly, so to manually return the accumulator from the function. So that's how the reduce method works. We always have to return the accumulator from each iteration. Now, usually that happens implicitly, like here, but you already know that this function here has an implicit return, right? But this is easy to forget in these cases, so that's why I'm emphasizing it here. So again, we always need to return in the end the accumulator. And so now this should actually already work. So sums, and indeed we get all the deposits and all the withdrawals. And this value should be the same, as this one here, right? But now we calculated it in a different way and put it directly in an object by using the reduce method like this. So that's great. And let's actually destructure this object immediately. So we can do this. So we need to now use the exact same names as here. So deposits and withdrawals. And so here we can now log these two to the console. And indeed, we now get these two values here. Now this works just fine already, but I don't really like this part here so much. So let me just show you another way in which we could do it. So I'm just commenting it out here. Maybe you actually like this part here more, but we actually have some duplication here. And so let's fix that. So this part here is very similar to this part here, right? All that changes is the deposits and the withdrawals. And so we can actually do this. So here we can now conditionally say that we want to select either deposits or withdrawals based on this condition, right? So using here the brackets notation instead of the dot notation. So in this case, we will want to get the deposits and otherwise the withdrawals. And so then it's onto this value that we want to add the current one. And here I probably have some spelling error. And so we get the same result, but I think that this way here is just a little bit cleaner. But in any way, what matters here is that we were able to create a brand new object based on the reduce method. And this can be really helpful in many situations. And so please take some time to review this exercise, because this was really a great use case on how to use something other than a primitive value as the accumulator of the reduce method. And I would even challenge you to do this with arrays. So as a challenge, I would challenge you to recreate any of the examples that we did previously in this section with map, filter, and reduce to use only the reduce method. And that is totally possible. And so, you can try that out. You don't have to, and I will certainly not do that now. But as an exercise, and to get an even better understanding of the reduce method, you could totally do that. Now, this lecture is already running a bit long, but I still have one more exercise here for you. So let's quickly do that. And this one will not have anything to do with the accounts now, but instead what I want to do now is to create a simple function to convert any string to a title case. So title case basically means that all the words in a sentence are capitalized except for some of them. So there are some exceptions. Let me try an example here. So this is a nice title would be converted to this is, and then the A is lowercase. So this is one of the exceptions. And then nice title. All right. So let's get to work here. So convert title case is going to be a function which takes a title and will then convert it. And so this is going to be a nice exercise combining string and array methods all in one function. Let me start by writing an example of a string here that we might want to capitalize. So convert title case. And let's actually try this one. And let's also try some more. This is a long title, but not too long. So just to see what happens here, and also just to put some of the different exception words in there. And is another title with an example. Like this. And so now we can worry about writing our function here. And let's start by creating an array which contains the exceptions, so the words that should not be capitalized. And the exceptions are a, n, the, but, or, on, in, and with. And there might be some other exceptions here, but this is just an example. You can always search for title case on Google and see the exact rules if you want to make sure that this really works. All right. And by the way, it is a bit of a common pattern to create an array of exceptions and then use that for some computation further down the road. I've done this myself many times, and so keep this technique in mind. But now let's go on to the actual conversion. So let's call it title case. And so, of course, we must work on this title argument that comes in. And so what should we start by doing? Well, first of all, let's do something that we should many times do with our input strings, as I mentioned before, which is to convert them all to lowercase. And this is especially important in this case because we are now working with capitalization. So we will capitalize some of the words, and so they should, of course, all be lowercase to start with. So that's then going to affect like this or this word here. Then we need to capitalize each word here individually, of course. And so we need to be able to work individually on each of the words. And so whenever that is the case, we need an array, right? So we need to split this string into an array so that these words, which are separated by spaces, each of them are going to be one of the elements of the array. So split, and then by the empty string. And then by the space character. And this is, of course, far from being done, but let's nonetheless already return this just to see if it works. Okay, so this is exactly what we just did. And so now let's work on these words. So basically we want to now go through the array and capitalize each of the words that is not in the exceptions array, right? So here, for example, the A is in the exceptions array, so we don't want to capitalize this word, but we want to do it for all the other ones. So basically, we want a new array with all of these same words here, so the same 5 elements, but some of them capitalized. And so again, whenever we want a new array of the same size as before, we use map. And so now finally, our old friend map comes into play again. So in this array, each element is a word, so let's call it that. And so again, we want to capitalize it. So let's just do it for starters for all of them. And remember that one of the techniques to doing that is to take the first character of the string, so like this, and put it to uppercase, like this, and then we simply add the rest of the string to it. Remember? So we did that previously. And so the rest of the string is basically taking everything starting at position number 1. So let's check that. And indeed, it worked beautifully. Now the only problem is that we have these exceptions here. So we have an A here and a but, and here is a with, And so we want to now use the exceptions array to exclude them. So how should we do that? So excluding kind of sounds like filtering maybe, but that's not what we want here. Because we still want to keep an array of the same length, we just don't want to apply this here to all the words. And so what we're going to do here is another logic. So we will do exceptions, and then we are going to check if the current word is included in that array. And so for that, we have another array method, which we studied many times before, which is called includes. So here we are checking for that word, and then, as you know, this will return a Boolean, so true, false, and then we can use that Boolean to basically ask if the word is an exception or not. So if the word is indeed included in the exceptions, then we want to simply return that word, right? And only otherwise we want to then return the capitalized version. So let's check. And indeed, that already worked. So a and but, and down here the with, are now no longer capitalized. Let's actually change or fix that here. Exceptions like this. So that looks better. So again, let's go over that logic here. So if the current word, so for example, this a here, is included in this exceptions array, then simply return that word. So without any modifications. But if not, well, then capitalize it according to this rule or this technique here that I demonstrated earlier. And so after that, it is actually really easy. Now all we have to do is to join the array back with the space, and there we go. That's actually it. I noticed that I just forgot one word here, which is and. So that's also an exception. Let's give it a save. And so this creates this weird situation where the first word of the title is actually not capitalized. And of course, we don't want that. But that's actually an easy fix. All we have to do is, in the end, then capitalize that entire title case, right? So basically doing this here on the final output that we have here. But let's not copy this. Let's instead refactor this into a standalone function. Let's put it in here actually, because we don't need this function anywhere else. So capitalize, it takes a string, and then here instead of word, we will use string to make it a general function, and then here we will call it with word. Right, so everything works the same. And then, as I mentioned earlier, when we return the title case, we simply capitalize it again. So just to make sure that a situation like this here does not happen. So title case, and here we go. Problem solved. Nice. So I hope that these were 4 nice examples for you to practice these array methods even more, so that you are now ready finally for the final coding challenge of this section. So let's go there right now. Welcome to the final coding challenge of this section. And this one can really be seen as a final test of this section. So we're going to practice most of what we've been doing here. And so let's get started. And in this challenge, we are back to Julia and Kate studying dogs. And this time they are studying whether dogs are eating too much or too little. All right. So eating too much means that the dog's current food portion is larger than the recommended portion, and eating too little is the opposite. And then there's also eating an okay amount, And so that's when the dog's current food portion is within a range 10% above and 10% below the recommended portion. And we will check that out in detail in a second. Okay, and so here are your tasks. And actually, each of them can be seen as a separate challenge. So there are 8 of them. So this is going to be a long one. And some of them are actually a little bit tricky, so a bit hard to solve. And that is one more time on purpose, so that you can actually challenge yourself and try to do a little bit more than just what we learned here in these videos. And as always, if you cannot solve one of them on your own, then just go ahead and watch the solution and then go back to the next point. All right, now anyway, let's get started here. And the first task is to loop over the array that contains the dog objects. So that is this object here, and this is the data that we're going to work with. So it's this array called dogs, and in each position of the array, we have one object per dog. All right? So your task is to loop over that array, and then for each dog to calculate the recommended food portion, and then to add it to the object as a new property. So do not create a new array here. Just loop over the array that we already have and add the recommended food portion as a property. And so I hope you know which array method you need to use for that. And to calculate that recommended food portion, simply take the weight of the dog and elevate it to 0.75 times 28. Then, next up, find Sarah's dog and log to the console whether it is eating too much or too little. Now in this one, it's important to keep in mind, or important to notice, that these owners are actually inside an array. And so this makes this task a little bit more tricky. And so again, that is on purpose. Next up, create an array containing all the owners of dogs who eat too much. So call this one owners eat too much, and then an array with the opposite. So with owners of dogs who eat too little. Then log a string to the console for each of the arrays that we created previously, like this. So Matilda, Alice, and Bob's dogs eat too much. So that's based on this array, and then based on this array, a string like this. Okay. Then afterwards, log to the console whether there is any dog eating an okay amount of food. All right. And so let's take a look at what an okay amount of food actually means. So here we have this hint too. And so being within a range 10% above and 10% below means that the current food portion, which is stored here in this property, should be greater than the recommended food portion that you calculated before times 0.9. So that's 90%. And at the same time, it should be less than 110% basically of the recommended amount. So these two conditions here at the same time mean that the dog is eating an okay amount of food. So basically, it's what we see here. So the current portion should be between 90 and 110% of the recommended. Then number 7, create an array containing all the dogs that are eating an okay amount of food. And I want you to reuse the condition that we created before here in number 6. Finally, create a shallow copy of the dogs array and then sort it by the recommended food portion in an ascending order. Now just keep in mind that the portions are inside the array's objects. Okay, so to sort this array is a little bit trickier than what we did before, because the value is now here inside of an object and not just in the array itself. But the way that we write the callback function is pretty similar. So we will still have the A and B parameters, but these are now objects. And so to compare the recommended food portion, you will have to get that property out of each of these objects. So that's it. It's probably going to take you some time, but what matters most is that you practice and that you don't give up. But anyway, let's take now like half an hour or even 1 hour to solve this one. And then I see you back here. All right. So let's get started with the solution. So the first one is to calculate the recommended food for each of the dog. Now, as I said, you should not create a new array, but simply loop over the already existing array. So this dogs array. Actually copy it here. So copy. All right. So looping over this array, and then to each object, we want to add a new property. And so the for each method is the way to go here. Then each element is a dog. And what we want to do is to add a property. So dog dot recommended food is equal to dog dot weight elevated 0.75 times 28. And now let's take a look at the dogs. And indeed, now they have the recommended food. Now let's just get rid of this decimal part here. So let's say here math.trunc. So we used this one before. We simply truncate. So we cut the decimal parts. And so that's number one. And now number two, let's check it out again. So we need to find Sarah's dog and then log to the console whether it's eating too much or too little. So basically we need to find the object here. So in this case, that's going to be this one. So we need to find this object and then compare the recommended food we just calculated with the current food. Okay, so the trickiest part here is going to be to find the owner. But I believe we can do it. So let's call this one dog Sarah. Then it's dogs. And we use the find method because we want to find one element of the array based on a condition. So in each iteration, we have one dog. And now we want to take dog.owners. And now this itself is also an array. So it is this here. And what we want now is for this array to include Sarah. And so we can do this. Includes Sarah. And that's it. This is how we get our true or false value. So remember that in the callback of the find method, we need to return a true or a false value. And then the find method will return the first element for which the condition is true. And in this case, we get the true or false value by calling the includes method on the owners array. And so when the array of owners includes Sarah, then that condition is true, and then we are going to get this object. So let's just make sure here. And let's see. And indeed, it is the correct object. We need some more space here. This we don't need anymore. And now we just need to log to the console whether the dog is eating too much or not. And we already know that it's eating too much because the current food is 275 and the recommended is 191. So let's log. Sarah's dog is eating. And here I'm going to use my old friend, the ternary operator. Sarah.current food. If it's greater than dog Sarah, the recommended food, well then here we want to have much. Because in this situation, the dog is clearly eating too much. Oh, and of course this needs to be here inside the curly braces. And here, now it's correct. So we're asking basically this question. So if the current food is more than the recommended, then the dog is eating too much, and else too little. And so indeed, Sarah's dog is eating too much. So that's the conclusion we had already reached by looking here at the numbers. Okay, moving on. Let's take a second here to look at the exercise again. So create an array containing all owners of dogs who eat too much. So let's copy this name, and then also one where they eat too little. Okay, so how are we going to do that? Well, we know that we want a new array based on the existing dogs array, right? And we want to create this new array based on a condition. So once again, we want to compare the current food to the recommended food. All right, and therefore the correct method to use here is the filter. Okay, so in each iteration we get a dog, and we're going to return whether this dog's current food is greater than the dog recommended food. Because here we are looking for the dogs that eat too much. And so that means that the current food is greater than the recommended. All right. So this will give us the dogs, but let's start by taking a look at this variable for now, even though we want the owners. So this one doesn't show it to us, but yes, so this dog here is eating more than the recommended, right? Now, we want to get the owner, or actually the owners. So again, we want to create a new array based on an existing array, and this time this new array should have the same length as before. We simply want to take something out of the original array and put it into the new array. And so that means we're going to use map. So once again, we have a dog, and we want to return the dog.owners. All right, and now we have an array of arrays where one is Matilda and the other one is Sarah and John. And so finally, the next step to transform all of this into just one array is to call flat, right? And so indeed, we end up with this array with just one level and with all the owners of all the dogs that eat too much. So great. And maybe you can see here that we can actually do even better, because whenever we have a map combined with a flat, we can instead use flatMap. So let's transform this here into flatMap, and then we don't even need this part, and the result is the same indeed. Okay, and based on this one, we can easily create the owners where the dogs eat too little. So all we need to do is to invert this sign. Let's get rid of this one here. And so these are the other three owners, basically. Okay. Next up, our task is to create some strings. So let me just copy the strings. And so that's based on the arrays that we just created. All right, so these are the two strings. And actually, they will not be the same. So this is just an example. So here we see Alice, Bob, and Michael's dogs are together, and here they are not. So the string will be different, but that doesn't matter. So what matters is that here we have dogs eat too much. And so now all we do is to take the owners that we already have, eat too much, and essentially join them together using the separator string of and, like this. And so now we get this array here, Matilda, Sarah, and John, dog. So let's just add this, eat too much. And now the other way around, eat too little, and here too little as well. Beautiful. So we're making good progress here. Let's move on to number 5. So log whether there is any dog eating exactly the amount of food that is recommended. So whenever you see the word any, you can think of the sum method. So remember that the sum method will return true if at least one of the elements in the array satisfies a certain condition. So log to the console dogs.sum. And so, one more time, we are comparing the current food with the recommended food. And this time, we want to know if there is at least one dog eating exactly the same amount as the recommended portion. And so we use the equal operator here. So current and recommended food. And, well, there is none. Let's take a look at our dogs here just to confirm that. So these are different, these are different, these are different, and also probably, yeah, this is also different. And therefore, if all of them are false, then the sum method also returns false. All right, number 6. Log to the console whether there is any dog eating an okay amount of food. Okay. And so now this formula here comes into play. Let's copy it just so we see it down here. And so once again, the goal is to simply return true or false whether there is at least one dog eating an okay amount of food. So we need the sum method again. And now this a little bit more complex condition. So dog.the current food portion needs to be greater than the recommended times 0.9. So that's 90%. And then at the same time, so this, now let me just copy it here. So at the same time, the dog should also be eating less than 110% of the recommended amount. And so now we get true. So there is at least one dog, but we don't know how many. And so that's the task basically of the next point, which is to filter out all the dogs that are actually eating this okay amount of food. And for that, we should also export this condition into a separate function. So this is really just a function, right? So we can take it and store it into its own variable. And let's call it check eating okay. And then simply the function. And so here we can then use that function. And yeah, we still get the same result. And now, as I was just saying, the goal here is to create an array containing only the dogs that are eating an okay amount of food. So we want a new array based on an existing array, but only with some of the elements. And so it is time again for using the filter method. So dogs.filter, and now this is very easy because we already have this condition callback function here in this variable. And well, we only have one dog in this condition, as you see. So that's Michael's dog, where the recommended food is indeed pretty close to the current food. And so we consider that this is an okay amount of food to eat for the dog. Okay, almost ready here. So I told you this is a long one, but I hope you're having fun with this one. This kind of seems like a real world challenge. So like a real world task, doesn't it? So I took quite some time designing this challenge, and even that was also a lot of fun. But anyway, let's now create a copy of the dogs array and then sort it by the recommended food portion. So let me actually copy this so we don't forget what we have to do here. So we start by creating a copy. So docs.copy, no dot, of course, just the name is docs.copy. And so let's use docs.slice for that. And actually we can call the sort method then immediately on that. Okay, so here we are going to need a callback function as always, which is the sorting function. And this always has A and B as the parameters. So we could call them something else, of course, here, but I like to always call them A and B. And actually, we don't even need this block here. So remember that before, when we wanted to sort an array in an ascending order, we simply would do A minus B like this. But this was when we had an array simply like this. So just with numbers. But now we have these numbers here in objects. And so A and B are now the objects. However, the values that we want to subtract are in these objects, and we can simply get them out of there. So we want to sort by the recommended foot portion, and so let's simply do this. And that's actually it. Let's call this here docs sort, sorted, and then let's log that to the console here. Docs sorted. Let's see. And yeah, that worked. Oh, actually, we cannot see it yet. So yeah, here is the recommended food. So we start with the lowest one, then 191. And you see that indeed it is in an ascending order, 284 and 376. Okay, so that worked. And so we finished this coding challenge. Phew, this was a lot of work. And as I just said, also a lot of fun. And I hope you felt the same, and also that you felt the same for this entire section. So this project was a great project in my opinion. It was a lot of fun to build it together with you and to put it together and design it in the first place. So I hope you're proud of what you achieved here. And one more time, I want to congratulate you for making it this far and still sticking with this quite long course. Anyway, with that, I see you in the next section where we will actually continue building on this project by adding a couple of new things to it.